Hi everyone. Today we are here to present our idea about intelligent management of industrial design models. So first of all, thank you for joining this Tech@Lunch session. We are here with Muharrem Challenger, which is the promoter of this Tech@Lunch idea, and also professor and core lab manager of enzymacosis core lab at University of Antwerp. I am business manager of enzymacosis as well. So I will continue with my presentation. But before, I want to remind you some remarks. First of all, the cameras and microphones of all participants should be muted. So we did it for you. So you can ask your questions after I completed my presentation during question and answer session. So, by the way, we are recording this video, this event for you, and we will share it with you, so you don't need to record it. And while we were talking about the models in industry, we can give many examples. For example, simulating models under system architecture category. We can talk about function modeling models like functional flow block diagram, or most of us know architectural and compositional models as well. But today we will talk about 2D or 3D design files, CAD files indeed. So we will share our information and our experience with you about managing of them and what kind of activities we are doing in our core lab. So why you wanna actually, maybe you ask that, why are we doing model management? So what is model management indeed? We can list many kind of topics under model management. For example, finding similar product designs, finding similar and equivalent parts. You maybe want to do detailed similarity analysis on your design files during manufacturing or production designs. So you can want to find product families, or you can find a model based on some search keywords or search parameters. You want to complete a partial model depending on previous configuration in your company. So these are different topics we can list under model management. So you can use your legacy model available in your repository. So you can provide some partial designs, the rough design, or you can also provide design or catalog design of the parts. So I can give an example from product chain. This is so general and simple example indeed, but we can understand the topic better. So here in the manufacturing or production, there are three stakeholders. These are first is supplier, second is company, and third is customer. So supplier giving us some components, product parts. If we are a company, we are producing a product, then we are giving it to customer. But what if customer wants a specific and customized design from the company? So the company each time will design we'll do a new design for the same product, same bug, but customized product. So we want to actually prevent this redesigning of same product indeed. So we are saying that let's find similar designs that we did already. We can do some updates on these designs while adding some functionality, while adding some updates or innovation on that. So this is one dimension of the idea that we are talking today. There are many things we can do with also intelligent model management. If you don't have some components while producing a product, so for example, if there is a shortage, or if the stakeholder or if the supplier cannot supply that product part, you can find a similar one using similarity technique. So if you want to add new insight, new innovation to your specific or to your certain design, you can use the previous one, and you can only make some updates on your designs, as I said already in this presentation, or you want to find similar models while by entering some search keywords. So you want to see maybe similar models in your repository. You can use these kind of things, and what we want to do at the end of the day, we want to do shorter time. We want to provide shorter time to market for more variance, and we want to decrease development case design. We want to decrease the time while designing a product or product parts. So there are some available commercial tools, of course. We analyzed all of them in literature and also in technological tools. So Cadenas and CatSeek are maybe most popular, one of the most popular cases. Tools are available now. So when we analyze them, of course, there are some limitations. So then we said that maybe we can propose an idea to solve these kind of limitations, to remove them. For example, CatSeek is aiming finding cheaper alternatives for similar parts. So it cares about the dimension of price actually. So, and the pilot study was realized on 350 CAD files. That means there is no learning algorithm in the background. So they work on these CAD files, and they found some similar cases. So this is not enough for providing efficient similarity case. So Cadenas also supports finding similar models, but to the design models. So we want to do something also for 3D models because the companies don't deal with only 2D designs. So this is actually some limitations that we realized. Of course, there might be more. Of course, there might be some other issues. So we shared some documentation of these tools with you. You can look at it when we share with you the presentation. And if you don't use learning technique, if you don't consider the previous cases in your company, so you can skip some, for example, unexpected cases. So we want to prevent it as well. If we talk about our way of working, now we will also demonstrate the proof of concept to you, but we have 3 steps. We have 3 main steps in our approach. First of all, we are getting data and creating our data sets. And then we are doing pre-processing techniques. For example, we are converting your step files to JSON, more structured way. Then we are doing graph transformation on them. And after graph transformation, we are doing vectorization. And from these vectors, we are getting features, and we are creating vector space model and feeding our training model. After finding best learning model, we are finding a category of your document and then calculating similarity with the others in that category. So this is basic part indeed we can demonstrate to you today. So we can talk about the real company integration. For example, as you can see, there is a 3D dimensional CAD designer available here, and we can transform this step file to graph-based data structure, and then we can do vectorization, and we can calculate similarity between the others. In the application side, you can ask us, how did you do your proof of concept, and how we found the common and publicly available data set. Of course, we are working on this study more than 1 year, maybe. So we did many proof of concept and applications on that. And the biggest data set available in the state of the art is sketch graphs, having 50 million sketches of some designs. Of course, there are some basic, simple or complex categories are available. So we will show the results, how our tool is working on different kind of categories, like simple designs, on medium-sized design, or on complex designs. So we are transforming our models, our geometrical models, to this kind of graphs, and then we are training our system with the data that we are extracting this graph data structure. Now I will share a demo with you. I think sorry. Here is the demo. I will do it full screen. First of all, we are uploading. You can upload all your documents here. For example, of course, we are training system. Before this is test case, and you are uploading documents. For example, how many documents you wanna find similarity. So upload them, and you can see the process here. It doesn't take so much time because we are doing it really efficiently and using parallelism architecture. So you can categorize your files. For example, here we will choose 3 categories because we will categorize them: simple, medium-sized, and complex documents. So this categorization process, by the way, depends on the how can I say, dimension of the design. Here we choose one of them. This is really simple because it's under simple case, a simple illustration. So you can see the generation of graph structure, and you can see the most similar case to this actually to this drawing. So we are going with medium size, and this is the drawing having medium complexity, and you can see the also graph here. If the graph is bigger, of course the user interface is going a little bit narrower, and so, but we can set it. So if you check the similarity, you will find that this item is similar with the first one that we selected, and similarity score is 74%. And then we are choosing a complex, relatively complex file, and then we are calculating the similarity. So we are finding similarity with this shape around 77%. So here you can see the graph representation of our design. So actually, as I said, we are getting all the information from graph structure because we want to make common data structure while formatting that step files. So why we prefer doing graph transformation? We are also calling it canonical transformation. So thank you so much for listening to us. I can get your questions.
Okay, thank you, Fatma.
Thank you so much.
There are no questions so far. So I suggest we wait a couple of minutes to see if there are questions coming.
Sorry, I forgot to mention about something. May I go back to my presentation?
Okay.
Can you see my presentation?
Can you put it in full screen?
Okay, I will do that. By the way, as I said, we are doing this CAD file analysis during maybe for more than 1 year. We are doing it also in IMORE project indeed. So IMORE is a Evo project that is in gate 2 for now. So we have this kind of user interface. You can upload your CAD files, and then you can find the similar files between your proposed design. And for example, if you upload a partial design step file, we are finding which kind of elements that your file including, and then we are finding, for example, most similar CAD designs. You can increase the number, by the way, while this load more button, while pushing this load more button, and you can see the similarity by checking with this visit documentation. So this is our IMORE approach, that we are extending our similarity work. There are also other optionalities, other functionalities in our IMORE project. If you wanna ask many other questions, you can also contact with me or Professor Muharrem Challenger about IMORE. You can join and you can support us with your feedbacks as a company. Thank you so much. So sorry for this inconvenience thing.
Okay, thank you, Fatma. There are still no questions, so I suggest we wait a little bit longer, but otherwise we can close the session. So if you have any questions, you can place them in the Q&A chat box, which is in the top right of your screen. And we'll try to answer it.
Maybe while the people are doing their questions, I can add some comments. The main idea by Fatma is that we're working on similarity set, but of course we can also include the metadata that you may have for that design. For example, if you have your PLM, if you have data about the material or other information about the design, we can also add these kind of information to the similarity search. So we can semantically search not only the structure of geometric structure of the model, but also the kind of textual information and metadata that you may have about that product. Then we can compare these combined information, structural and textual information, semantically, and find the closest one for you. So, for example, if you have legacy models, legacy data about those models, this can be simulation results or other information linked to that model. We can find the similar one for your new design. So you can reuse the available model for your new case.
Okay, great. There are no questions coming, so we already gave some time to ask questions. So I suggest we now close the session. If you still have questions afterwards, you can still publish them in the Q&A chat box, and we will see them coming. And if it's relevant, then we can always reply via email afterwards. So don't hesitate to ask questions if you have. And then I'll leave the floor to Fatma to officially close this session.
You are muted, Fatma.
Okay, so sorry. Thank you so much for listening to us. So we are waiting your questions. And I'm closing the session.
Thank you very much.